Hey everybody, it's John here. In this video, we're going to talk about the domain of logarithmic functions. We're also going to talk a little bit about the graphs of a logarithmic function. And maybe we'll get into natural logarithms a little bit. But the great thing about logarithms, if you can remember the definition of a logarithm, is that it's basically just an exponential function or an exponential equation rewritten to be solved for the exponent. So it turns out that exponential functions and logarithms are inverses of each other because one undoes the other. If I raise something to a power, a logarithm will tell me what that power was if I knew what I was raising to. And so it kind of undoes they undo each other, okay? And so the benefit here is if I know about the graph of an exponential function, then I can figure out stuff about the graph of a logarithmic function just by switching all the x and y coordinates, because that's what an inverse does. It switches the x and y coordinates. And you can see even here that the exponent is a y instead of an x, and then the output's an x instead of a y. So a logarithm is basically an exponential where I've switched x and y and then solved for y. So what we're going to do is to find the domain of these logarithmic functions, we're actually going to find the range of the exponential function that goes along with it. So if we're looking for the domain of the following, okay, log base 5 of x. So if we think of this as y equals log base 5 of x, what we're really interested in is if we rearrange things here, this would be 5 to the y equals x. So if we switched x and y here, we'd have 5 to the x equals y. So if we look at this function here, which is the inverse of this logarithm here, if we know what the range is for this graph, then we know what the domain is for this graph. If you remember from our exponentials last week, this is an exponential growth. It goes through 0, 1, so it looks like this. Okay, the domain here is all real numbers, because all exponentials have a domain of all real numbers. But the range here, we have this horizontal asymptote at y equals 0. So the range is from 0 to infinity. So that means the domain here is from 0 to infinity. So the domain of a logarithm is the range of its inverse, which is the exponential. Now, an easier way to do this is we can always just set what's inside the logarithm greater than or equal to 0, and that will give me my my domain. It doesn't make sense it doesn't make sense to plug in a negative value here, and it actually doesn't make sense to plug 0 in here, because the question would be, what would I raise 5 to get 0, or what would I raise 5 to get a negative number? And it turns out there is no value, because look at this exponential up here. Look at this graph. No matter what value I raise 5 to, I'm just going to get something closer and closer to 0 on this end, and I'm just going to get a really large positive number on this end. And so there is no value that I can raise 5 to get 0 or anything negative. So looking at g of x here, instead of figuring out what the inverse function is and how it's shifted up or down or whatever it happens to be to find the range, what I can do instead is just say, well, I just want to know when 2 minus x is positive. I want what's inside my logarithm to be positive, because when I raise 3 to any exponent, I'm going to get a positive number, right? So I can subtract 2 from both sides. That gives me negative x is greater than negative 2. And then I can multiply both sides by negative 1 or divide by negative 1, however you feel like doing this. But remember, with inequalities, if you multiply or divide by a negative number, it switches the sense of the inequality. So now instead of being greater than, it's less than 2. And so my domain here, written in interval form is going to be from negative infinity all the way to 2, not including either negative infinity or 2. Okay, because if I plug 2 into here, I'm going to get 0. And what do I raise 3 to get 0? Again, there is no such number at all. Okay, so that's the domain. So I want you to understand why we can use the inverse, but I also want you to know that the easiest way to find the domain of a logarithm is just to set what's inside the logarithm greater than 0 and solve. So really quickly, I'm going to sketch the graph of log base 3 of x. But to do that, I'm going to first graph the inverse, which is 3 to the x equals y. Okay? So this equation can be written as 3 to the y equals x. If I switch x and y, I get the inverse of this. So here's my inverse, which I'm going to graph in red. I'll graph the inverse in blue, and we'll graph the actual equation in red. How about that? Just change it up, okay? So we know that y equals 3 to the x has a horizontal asymptote at y equals 0. It goes through the point 0, 1, and it's growth, so it's going to be hugging this line, and then it's going to come up really quickly. And I know I'm not hitting the correct points here on the y values going up, and that's fine. Okay, I just want the basic shape. It's growth. Okay. Now also remember that inverses, and we talked about this back in the first unit, inverses are symmetric about the line y equals x, because if you switch the x and y coordinates, any points where x and y are the same, you're going to end up on this line, and so we're symmetric about this line y equals x. So if I wanted to graph the one point that I know on my original function, I would switch x and y. So this is the point 0, 1, so the point 1, 0 is going to be on my logarithmic function. And also, if I have a horizontal line as an asymptote in my original, that means, so something like negative 10, and then a number really close to 0, means that I'm going to be really close to 0 down here near negative 10. And that horizontal asymptote is actually going to become a vertical asymptote on my logarithmic function. And so, again, if we're trying to mirror image this, then I'm going to go this way and then towards this vertical asymptote as I go down. So this red graph is what a logarithmic function looks like. So I'm going to erase the rest of this. This is what my logarithmic function looks like. If you want to draw in the vertical asymptote, you can. There's a vertical asymptote at x equals 0 instead of a horizontal one at y equals 0. And you can see it still has that like exponential shape, except now it's sort of flipped over that line, y equals x. I'm not actually ever going to ask you to graph a logarithmic function, but I think it is important that you understand the connection between the domain and range of an exponential and a logarithmic. So I'm not going to ask you, I'm not sure if I just said exponential or logarithmic, but I'm not going to ask you to graph the function of a logarithmic function. Okay? We'll talk about natural logarithms in the next video and continue from there.